Hi students, welcome back in my channel with Mr. Henrik. In this video, I will explain how we figure out the solutions of several integrations. As usual, before I begin this lesson, don't forget to take your pen and your notebook and also click like and subscribe for this video. Okay, I will begin with number one. Integrations e to the power kx dx. To find the solutions of these integrations, you have to use illustrations with new variable u. Okay, if u equal kx, it means du equal du dx. Yeah, du dx equal k, or du equal k dx, and 1 over k du equal dx. Okay, so it means these integrations we may writing as e to the power u, okay, times, they call it dx equal 1 over k du. So we may writing 1 over k du. And if we writing 1 over k in front of these integrations, it becomes 1 over k integral e to the power u du, like this. And the outcomes comes 1 over k times e to the power u, because integral e to the power u still e to the power u plus c, and it becomes 1 over k e to the power kx plus c. This is the outcomes of these integrations. For example, if you have problem integration like this, integral e to the power 9x dx. According to these outcomes, you may writing the solutions as 1 9th e to the power 9x plus c. Or there are another problems, e to the power 7x dx. According to these outcomes, the solution is 1 of 7 e to the power 7x plus c. Okay, that's simple. Next is one, integral sine kx dx. If u equal kx, it means du equal k dx. Okay, and 1 over k du equal dx. So this integration we may writing integral sine u dx 1 over k du becomes, and if you writing 1 over k in front of this integration, becomes into 1 over k sine 1 over k times integral sine u du. And next it becomes negative 1 over k cos, cosine u plus c. And the outcomes, -1 over k cosine u plus c. Yep, that one. For example, if you have problems integration sine 9x dx. According to these outcomes, you may write in the solution -1 nth sine, cosine, I mean, cosine 9x plus c, okay? Or, for example, integral sine 2x dx. Solution, -1/2 cosine 2x plus c. Okay, simple, I think. Next, integral cosine kx dx. Yeah, using u equal kx. It means du equal k dx. And if we simplify, if k move, it becomes 1 over k du equal dx. Okay, so we may writing these integrations, cos kx become cos u, okay, because kx equal u, and dx equal 1 over k du. 1 over k du. And if you're writing 1 over k in front of this integration, it becomes like this, 1 over k integral cosine u du. 1 over k can move in front of this integration because 1 over k is constant number. So the solution 1 over k integral cosine u equal sine u plus sine u, I mean, okay, sine plus sine u, okay, sine u plus c, and it becomes 1 over k sine, recall that u equal kx, so sine kx plus c. Okay, for example, if you have problems integral cosine 7x dx, the solution is 1 over 7 sine 7x plus c, according to these outcomes. Or, for example, if integral cosine 4x dx, the solution is 1 over 4 sine 4x plus c. Okay, very simple. Next one, integral 1 over y dy. Okay, I will begin with these illustrations. If y equal e to the power x, okay, if y equal e to the power x, according to logarithm or learn rule, to find x, x equal learn y. Okay, yeah, such as logarithm as well. Yeah, for this rule. Okay, now look for y equal ex. Yeah, if y equal ex, it means dy over dx, dy dx equal ex as well, because derivative of or differentiations of ex still ex. Yeah, and look that y equal ex. It means dy dx, dy over dx. We may writing dy dx equal. We may writing y here. Okay, why? Because ex equal y. Yeah, here. And also we may simplify these equations by be dy over y equal dx. Like this. Okay. Now I'm gonna move to this space. I'm gonna move to this space. Okay. And for these equations, if we give integration, becomes like this: integrations dy over y equal integration dx. Okay. Or integral 1 over y dy equal integration dx. Integration dx equal x plus c. Okay, they call that x equal ln y. So we may writing x equal ln y plus c. And so integral 1 over y dy, the outcomes is ln y plus c. Okay, for example, if you have problem, integral 1 over 1 over x, for example, dx. Solution is ln x plus c. Okay, or integration 1 over z dz. The solution is ln z plus c. Okay, that's simple. Next, this integrations of first differentiation of x over fx. Also, I will use illustrations if u equal fx. Okay, if u equal fx, it means du equal f, yeah, first derivative of fx dx, like this. So if du equal first derivative fx dx, yeah, these integrations we may writing integration du over u, because fx equal u, this one. So solution is ln u plus c, as I explained on my previous slide. Okay, ln u plus c, yeah, equal ln fx plus c, like this. Okay, so very simple. For example, if you have a problem like this, integral 2x over x squared dx Of course, the solution learn x squared plus c. Okay, or if you have problem like this, integration 4x, okay, 4x cubed over x over 4 dx. So the solution becomes ln x to the power 4 plus c. Okay, so simple. Next, this one, integrations. First derivative of x times fx to the power n dx. Okay. As usual, I will use this illustration. U equal fx. If u equal fx, it means du equal f first derivative of x dx. Okay, and for these integrations, we may writing like this: x to the power n f first derivative fx dx. Okay, recall that fx equal u, so we may writing this integration is going to be u to the power n, and first derivative fx dx equal du, so du here, and the solutions becomes 1 over n plus 1 u to the power n plus 1 plus c. Okay. Or becomes u to the power n plus 1 over n plus 1 plus c. Recall that u equal fx, so we may writing fx over n plus 1 over n plus 1 plus c. Okay, for example, if you have problem integration 2x times x squared power to power 4, for example, dx. According to this illustration, according to these outcomes, you may writing the solution becomes x squared power 4 plus 1, it means 5 over 5, yeah, plus c, and the solution becomes 1/5 x power 10 plus c, like this. Okay, so very simple. Okay, students, if you have any questions, or maybe some of you not understand yet regarding these explanations, you may ask me or send me your message, your questions through this email, henry.academy21@gmail.com. Thank you for joining with me in this lesson. See you